Recording now. Hello, welcome back to our channel. We will be showing you our distributive property and simplifying expressions.
Thank you. Alright, so our learning target for today says, I can simplify. I don't need you to repeat after me. Expressions using the distributive property and combining like terms. I'm sorry, are you not entertained? Now, we're going to start on the right side, and I don't know why I didn't make it so that we start on the left. I don't know what happened. So we're going to start with simplifying expressions. We're going to define these terms. We're going to do some baby examples, and then we're going to distribute, and then we'll unicorn. Everybody ready?
No.
Okay.
Like term.
Like term. It looks like.
Like term.
All right, who can tell me what a constant is? Take a point if you said the number without the variable or the thing that stays the same. So, stays the same. Number without a variable. What's a variable?
Something that represents the unknown.
The unknown number, it's a letter that represents a number, so it's usually the letter, right? Does it change?
Yes.
Yes. It can be anything in the whole wide world. Alright, so variable changes. It's the letter that how do I want to word that?
Under that represents any number.
Represents an unknown. That's how we'll do it. It's just alright, what's a coefficient?
Isn't that when it has that variable with it?
Yes. Awesome. Take a point. So a coefficient is the number in front of a variable. So what's a term? It is, but kind of. You're close. So if I said, how many terms do you think we have here?
1, 2, 3, 8, 2.
It's one. No, 0 terms.
Are we here for 4 years for high school?
No, baby. That's not. You're going too deep with it. I mean, right here.
I thought you were talking about. I thought you were going to school. Therefore, yeah.
So we have to do this every day? Every day we have to do this. Covering your eyes isn't going to keep me from seeing you. It's not. Okay, that's great. It does count. It's a rule. And it's my classroom, and it's my rule. Not Jarrett's classroom. So Jarrett has to do the push-ups. Sure. We will pause after this just for you. Now, this has 2 terms. 2. This is a term, and this is a term. They're separated by a plus or minus sign. Now, is 7 the constant, variable, or coefficient? Okay, what's x? What's 4? Okay, so terms are constant. Ooh, I need to change colors. Constant or letter separated by a plus or minus. Because if you divide, that's a great question. So if I said 1/4 x plus 2, that's still 2 terms. Because by plus or minus. Because division or multiplication, it just keeps it as 1 term. It's part of that variable. So it's just like how we said 4 times x, and that's its 1 term. This is the same thing. So multiplication and division affect what you plug in right there. Alright. Are we ready to combine some like terms? What are like terms?
Oh, like if there's 4A on this side, 3A on this side, or the same side.
Yeah. What is it, Jarrett? Wait, what?
It'd be like there's like a 4A plus whatever that equals another 3A plus whatever you can combine them.
You have to move them if they're on opposite sides of the equal sign, right?
Yeah.
But if they're on the same side, you can combine them. But what if I said 3x squared and 2x? Are those the same?
No.
No. They have to have the same letter and the same what? Starts with an E. Exponent, yes. Alright, so like terms. I'm writing this, I turned my paper sideways. That's all I did. Didn't go anything crazy. Same variable. Same exponent. Or constant. Constants are like terms. Are we ready?
No.
Okay. How about now?
No.
How about now? How about now?
Now
Okay, I don't know. It's Aldo. He's just living the dream, I guess. Okay, so what we're going to write right here is simplify each expression. And we're going to do 2 examples. Super crazy, I know. Are you okay? So the first one that we're going to do $33J squared minus 15 plus 16J squared plus 4J. This is our expression. Write it down. Don't say what. Don't say I don't understand. We're just writing something down. Now, to begin with, How many terms are in this example? 4. But we're going to combine like terms. Now, who can tell me what matches up with 33j squared?
16j squared.
And 4j.
Wait, is that a little negative sign for J?
It's not that.
But why not 4J? What's wrong? Oh, wait, it's still square.
Right there, negative square.
That's kind of J.
Oh, is that? Oh. I wrote it.
Because it's a negative.
Bless it. Okay. Now we do 33j squared plus 16j squared, and you get
49j squared.
49j squared.
Minus 15.
Wait. Now, do you think that the 4j should go next or the 15?
The
4j.
4j.
Why?
Because you go in order from greatest exponent to your constant. So the constant is always going to be the last thing. Always. Now, which one is our constant? 4j or negative 15? Negative 15, so it goes last. Do we have anything to combine the 4j with?
No.
So we write plus 4j minus 15. Boom, you're done.
That was good.
I know. Now, how many terms are in this problem now?
4.
3.
Yes. In the answer, there are 3. 1, 2, 3.
How did that go?
4.
I meant 3. I was I meant 3.
Okay.
I promise you.
All right, B, as in potato.
How about that?
Let's like potato.
She did now.
All right, negative 12a plus 33 minus 17a minus 19. Going crazy.
I know.
Put them together.
Yes.
I can answer.
Oh, wait, we're not all done writing it down.
I am.
Give everybody just a moment.
I was first.
Work it out without me. And then best friend's going to tell us the answer. Okay?
No.
This is the answer.
We're just combining it. No.
No, because we don't have an equal sign. So the difference between an expression and an equation is an expression doesn't have an equal sign. We're just simplifying. We're not going to go work it all the way out to find what J is. That's a great question, though.
Do you love unicorns?
I love all things.
Why not negative?
Well,
Yeah. Besides children.
yes.
Can I say the answer?
Logan's going to say it. You can say the next one when we distribute them.
Well, hold on. Is that a negative? Can you say that again? That's okay.
I'm sorry?
Is that negative? So you can.
Yes.
Oh.
Can you tell me the answer?
Oh, yeah.
Wait, can you combine 30 like negatives and positives?
Yes.
It's negative 29a.
No, I have to see where it would be.
Not right now. It's what?
Negative 29a
Okay.
plus 33. Oh, no.
It's 14.
Oh, I got it.
It's negative 29 plus 14.
Yeah, that's right.
If everybody at your table got it right, give your team a point. 33 minus 19 is 14.
No, we didn't get it right.
All right, are we ready to distribute? Do we have any questions about that problem? Okay, so we distribute when we have parentheses, and you use it when there's a letter inside the parentheses. Okay? What mathematical operation is the distributive property?
Multiplication.
Multiplication. All right. Simplify each expression. If it was an equation, would it say simplify or would it say solve? Solve. Awesome. I can hear you, baby. But I appreciate it, just in case. All right, so we're going to start with 4 times 7x squared minus 19. Now, before we distribute, can we combine any like terms in this parentheses? Because there are no like terms in the parentheses. So since we have no like terms in the parentheses, we distribute to the parentheses. Is everybody ready? You do 4 times 7x squared, which is 28x squared. Alright, then I do 4 times negative 19, and I get
Negative 7.
dun 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 dun.
Well, that's not hard.
That's it. Isn't it magic? Just a little bit. Alright, what if I throw a negative out front?
It's not going to
What if I say negative 3 times 15a minus 16? So we have negative 3 times 15a minus 16. Can we combine the negative 15a and the negative, I'm sorry, the positive 15a? Why?
Because they're not like terms.
Okay, so what do?
You distribute.
I distribute.
because there's a negative.
What is negative 3 times 15a?
Negative 30A.
Negative
What?
45.
Negative
45.
45A. I'm thinking of 3 plus
You're wrong.
15 plus 15. I don't know why.
You weren't thinking that either.
I was though.
We're thinking 15 plus.
Was? No, just say that.
All right, take a deep breath.
Plus 48.
Why is it plus?
Because
The positive. Yeah.
Okay, let's say it in a cult-like manner. A negative times a negative.
Negative is positive.
Again.
A negative times a negative is positive.
Why are you messing up the cult chant? All right, are we done? Circle it, heart it, baby Jesus it, cloud it, something. That's why I said heart it.
Oh, you did?
I did.
How do you make it?
All right, what if I throw a fraction out there? It doesn't. Hey, fractions are our friend, not food. Y'all have never seen Finding Nemo? What? Okay, so what we're going to do is we're going to still distribute it the same way. Now, are fractions division or multiplication? Division. Watch this trick. Okay, we're going to distribute. Now, I need everybody to look at the board. Draw your arrow and then look at the board. Four goes into 16. How many times? 4 times 3 is?
Can't you just multiply the Johnny?
I did.
I just did.
Do I need to show it again?
No.
For funsies? 4 goes into 16. How many times? 4 times 3 is? And what if I don't let you use a calculator? You're going to need to know how to divide and multiply. 4 times 3 is 12. Yes. I said 4 goes into 16. Hush. 4 times. 4 times 3 gives me 12. Now, if I do it to the next one, watch this next one. 4 goes into 12 3 times. 3 times 3 is?
9.
What?
Oh,
Who
3.
said it?
4 goes into 12 3 times. 3 times 3 is?
9.
what if the numbers are big and we can't do it in our head?
Learn your multiplication tables. I won't give you anything giant like that.
Oh, okay.
Yeah.
Do you just leave the exponent there?
Yes, because we can't do anything to the exponent.
Okay, unicorn time.
Unicorn time. Now, let's talk about how. Yes.
Can I get a new uniform sheet?
No.
Because look, the hole was not good.
You're fine.
So how am I supposed to put it in?
You're gonna turn it in.
Today?
If you finish, it won't take long. Now let's talk about how a maze works. Because apparently I have to explain these things.
A maze, really?
You would be surprised at the things I have to explain. Alright, so we're going to start here, and we're going to use the distributive property.
Okay.
So that means that we're going to do 4 times 2x, which is,
8x.
and 4 times 1, which is. So does that answer make you go right or down?
Right.
Okay, so then I'm going to color in the direction that I go, and I'm going to work out the next one.
Now, mark that, mark that.
Yes. Hey, we need the hole puncher over here. Where the hole puncher is, we need to pass it up front. Where the hole puncher at?
Don't ever say that.
Give me